Okay, so till now we have seen the fabrication process for fabricating NMOS and CMOS inverter, right? Just a minute. So today we will be seeing the one more technique called as local oxidation. So basically, local oxidation will is about oxidation. Okay, is about forming an oxidation layer, right? Okay. Now, the MOS transistors that comprise an IC that are fabricated in an IC, okay, must be electrically isolated from each other during fabrication. Okay, we want those components to be electrically isolated from each other, right? So they do not communicate among other, or they do not crosstalk with each other. Okay, because if they do so, then that's not desired. That is an undesired effect, and that will create problem while operation. Okay, so we do not want the different components to be electrically connected to each other unless it is there in the circuit. Okay, otherwise they should remain independent. They should not crosstalk with any other component. Okay, so there is a need of electrical isolation among different transistors that are fabricated on an IC, right? And to achieve this, okay, this process, local oxidation, is being used. So this is basically used to prevent unwanted conduction paths between the devices. The devices refer here the different components. What are the different components? Those different transistors, right? The N MOSFETs and P MOSFETs. So isolation is required to prevent unwanted conduction paths between the devices, to avoid creation of inversion layers outside the channel region of transistors, and to reduce leakage current. Okay, because inversion layer is used to form a channel between source and drain. Okay, and apart from this, we do not want this inversion layer to be created anywhere else. Okay, and also leakage current, to avoid leakage current, because if there would be an unwanted connection, there would be a leakage current. Okay, if there is no connection, no unwanted connection, there would be no leakage current. Okay, right. uh, to achieve a sufficient level of electrical isolation between neighboring transistors on a chip's surface, the devices are typically created in dedicated regions called active areas. We have seen this. The active area will contain the source, drain, and the channel region. Okay, where each active area is surrounded by a relatively thick oxide barrier called the field oxide. Okay, this is also called as locos. Locos is actually for uh, local LOC for local, oxidation for silicon. Okay, so locus is local oxidation for silicon. Okay, so these are the basic steps that are used to perform to fabricate locos in an IC, so that the components can be uh, isolated from each other. So suppose this is the active area that is required. So this is the active area, this is the active area. So it may happen that in this active area one NMOS may be formed, and this active area one another device, maybe PMOS, may be formed. Okay, so we do not want this NMOS to be communicating with this PMOS among this within this substrate, silicon substrate. Okay, so what can be done is that to introduce one insulator layer. This is the insulator layer, this is the thick insulator layer. Okay, that would separate and that would try to diminish any electrical connection that may arise between this active area device and this active area device. Okay, so how it is achieved is we start with the silicon substrate. Okay, and then we deposit one layer of pad oxide. This is the similar uh, silicon dioxide that we have already used. Okay, so it is also called as pad oxide, and on the top of it we deposit one layer of silicon nitride. Okay, now uh, this particular structure, okay, will define the region for active area. This particular structure will again define the active for region, will again define the region for active area. So there are basically two active regions, one here and the other one is here. Okay, so after securing the regions for active area, okay, now it is doped with P plus impurities here, here and here, right? And then it is doped with a thick layer of silicon dioxide. This is called as field oxide. This is the oxide layer, this is the oxide layer, this is the oxide layer, right? And then it is etched out, okay, etched out, so that the layer of Si3 and 4 silicon nitride and this thin layer of pad oxide gets removed from the top of the surface, and the active area is visible, the active area window is visible. Okay, this one and this one. So basically this particular region is to be etched out and this particular region is to be etched out. Okay, so what was the aim? The aim was to form one thick layer of silicon dioxide that would separate this particular device from this particular device. Okay, and also these layers are fabricated on both sides of the device. Okay, on the right side and on the left side also, so that if there is any other device present here, okay, then this will stop this device to communicate with this device also. That is not desired, right? Because this is just one part I have shown here, but it may happen that this substrate may extend to a large dimension, to a large distance, and it may contain several such devices. So each of those devices should be electrically isolated from each other. How it is achieved? It is achieved with the help of uh, local oxidation process. Okay. Hmm. Now there is one effect that is generally visible here is that if you pay enough attention here, you will see that this edge, okay, this particular edge is vertical before the deposition of thick oxide. Now, okay, now this edge or this one, all these four edges were perfectly vertical. Now when we deposit the thick layer on this silicon substrate, okay, the layers does not remain positive, because this thick layer of oxide tends to get uh, a bit inserted at the edges of Si3 and 4 silicon nitride layer. Okay, this also gets inserted below the edge, the corner edge of silicon nitride. So this effect is also visible here and here. Okay, so this is called as I think beak effect. This looks like bird's beak. Okay, so this is called as something bird's beak effect. Okay, so what happens is that, so because of this, the actual the original uh, the original active region gets reduced. Okay, this was the original active region that should have been formed, but because of this bird's beak effect, the look at this, now we have the active region, this one. Okay, this active region would be smaller than the actual active region that we wanted to achieve. Okay,